Scientists are re-engineering viruses to fight antibiotic resistance. The world is in the midst of a global superbug crisis. Antibiotic resistance has been found in numerous common bacterial infections, including tuberculosis, gonorrhea, and salmonellosis, making them difficult, if not impossible, to treat. We're on the cusp of a post-antibiotic era, where there are fewer treatment options for such antibiotic-resistant strains. Given estimates that antibiotic resistance will cause 10 million deaths a year by 2050, finding new methods for treating harmful infections is essential. Strange as it might sound, viruses might be one possible alternative to antibiotics for treating bacterial infections. Bacteriophages, also known as phages, are viruses that infect bacteria. Chirp chirp. Who's there? It's early bird tickets to TNW 2020. Come in. They're estimated to be the most abundant organisms on Earth, with probably more than 1,031 bacteriophages on the planet. They can survive in many environments, including deep-sea trenches and the human gut. While phages are efficient killers of bacteria, they don't infect human cells and are harmless to humans. Although phage therapy was used in the 1930s, it has since become a forgotten cure in the West. Although the treatment became commonplace in the former Soviet Union, it wasn't adopted by Western countries largely because of the discovery of antibiotics, which became widespread after World War II. Read, research, bacteria can change shape inside humans to avoid antibiotics. Bacteriophages are effective against bacteria because they're able to attach themselves to the cell if they recognize specific molecules called receptors. This is the first step in the infection process. After attaching to the bacterial cell, the phage then injects its DNA inside the bacteria. This causes one of two things to happen. After being injected with the phage's DNA, the virus will take over the bacterial cell's replication mechanism and start producing more phages. This process is known as lytic infection. This disintegrates the cell, allowing the newly produced viruses to leave the host cell to infect other bacterial cells. But sometimes, the phage DNA gets incorporated into the bacterial host's chromosome instead, becoming a prophage. It usually remains dormant. For more on this story, visit the news article link.